Hi, I'm Gregory. I've been using C++ since before Microsoft had a C++ compiler, and I'm still using it today. It's not the only language I use, but it's still a big part of what I develop with. And a lot of people ask me why, in a world that has C# I would ever want to use C++. So I thought I'd run by a few of the features that C++ offers that other languages like C# and VB do not. Most people know the first two on this list. C++ is the only language that comes with Visual Studio that can generate native code in addition to managed code that runs on the runtime. Great. And a lot of people know the interrupt story. C# and VB have two ways to interrupt old code. They can go through a DLL using pinvoke, DLL import, and they can go through COM interrupt. It's kind of slow, but works if you have an old COM application. C++ developers have another choice. We can use C++ interrupt, which used to be called It Just Works interrupt. It's the easiest for the programmer. Just include the header and link to the lib, and it's the fastest, the highest performant interrupt. And C++ has this reputation as being the language that's the fastest, that produces the small executables, that produces a tight code. And that's exactly what continues to happen with Visual C++ 2005. Been a lot of noise made about generics being added into Visual Basic and C# in this release of Visual Studio. Well, generics are in C++ as well, and so are templates. Mixing and matching templates and generics gives C++ devs the flexibility of things like template specialization and compile time generation of code. They can expose a generic interface to the rest of the world, puts them in a good place for continuing to interrupt with say, a UI written in C# or VB, while the central core of their application is still written in C++. The other things I'd like to talk about are things that are specifically unique to C++ that other languages really cannot offer. And I'll start with deterministic destruction. This is a piece of C#. Pretty familiar idiom. I'm going to work with a connection. I'm going to work with a command. And I want to make sure that I dispose both the command object and the connection object when I'm finished with them. In C# and VB, we have this using construct, and it works beautifully. But it's a lot of typing. You actually have to type, the 5 letters of the word using. You've got some indenting issues. You end up bringing your code all the way over to the edge of the screen. And it can get hard to read. The other issue with a using construct is you can, of course, forget to do it. So using saves you from remembering dispose and worrying about setting up your own tries and catches, and that's convenient. But what if you forget you're using? This is the C++ equivalent. The closed brace takes my objects out of scope. These objects weren't written in C++. They're framework objects written in C# or VB or I don't know what. They don't even have destructors. But when we hit the closed brace to take these guys out of scope, they're on the stack, or at least they appear to be on the stack. And when we hit the closed brace to take them out of scope, their destructors are going to go off. The destructor in C++ maps to a dispose method on the rest of the .NET framework. If I write a C++ class that has a destructor, that class will automatically implement iDisposable and expose a dispose method to the rest of all of the applications that may be using it. So here I take a non-C++ class, allocate an instance on the stack, it goes out of scope, the destructor goes off, which means dispose gets called. I don't have to remember to type using. I don't have to indent my code. It's simple and readable, and it taps into a paradigm that C++ programmers already understand and recognize. The other thing C++, of course, is all about is optimization. You would expect that any native C++ that I generated with the C++ compiler would be very well optimized, and it is. But so is my managed code. So is my IL. Even when I'm making verifiable code to use in a partial trust situation, my intermediate language is optimized by the C++ optimizing compiler. It inlines functions that need to be unlined. It unrolls loops. It hoists stuff out of loops that never changes and doesn't need to be inside the loop. It does all the sorts of things you would expect an optimizing compiler to do, and it does them to your intermediate language. So if you take the same piece of work and write it out in C++ and then in C#, compile them both, you'll get different intermediate language. You'll get faster intermediate language from the C++ version for the same piece of work. In addition, we have whole program optimization, which waits until link time to do some final bits of optimization between files, something else that the other compilers do not do. The other kind of optimization that's new in 2005 for managed code is profile-guided optimization. Some kinds of optimizations are really not possible by a compiler. You have to know how the application is used. Do I add more than I read or read more than I add? How many times do we usually go through this loop? You can't know that unless you're running tests against the code. So profile-guided optimization is a way to semi-automate the procedure of optimizing your code to match the way it's genuinely used. Here's how it works. First, you just compile your code into individual C++ object files. Then when you link those files, you turn on link time code generation to instrument your executable image. This instrumentation obviously makes the image a bit bigger and a little slower, but it's not your release version. It's for the next step. The next step, you put together a whole pile of scenarios. These are not your test cases, your edge cases, your corner cases, your weird things. These are how people actually use the application. And if people add 10 times more often than they read, then you run 10 times as many read scenarios as you do, or 10 times as many add scenarios as you do reads. You run your scenarios on the instrumented image, and this continues to build up, in addition to the output you're expecting to get from your tests, a series of profiles. And as you run more and more tests, you build up more and more profiles. When you think you're ready, when you think you've run enough profiles, you relink the original object files with the profile data and generate an optimized image. This image is anywhere up to 30% faster than the original optimized image would have been, because it's specifically optimized for the way your application is getting used. The final goodie that C++ brings to the table that the other languages do not is taking interlanguage work another step further. In any other language, you can obviously add another project to your solution, and my VB code can call some object that was written in C#, and my C++ code can call some object that was written in VB, as long as they're all on the runtime and they're all meeting the common language specification, and we're used to that. But that's 2 projects or more in a single solution, and it's 2 assemblies. What I'm talking about here is a single assembly that contains a mixture of, in this case, C++ and C# code. You only deploy one file, one executable. This is a C++ only feature. You compile your C++ code into OBJs, and you compile your C# code, rather than into assembly, into something called a net module. You can use a net module exactly as you would use an assembly. Add a reference to it, call things out of it. Then when you do your final C++ link step, it links all your C++ OBJs and the .NET module into a single exe. You can deploy just that one file with your mix and match of languages put in there together. In Visual C++ 2005, the language changes are really designed to pull together everything C++ devs love about C++ with everything .NET devs love about the CLR. So C++ is all about deterministic destruction, not of memory, but of unmanaged resources like files and database connections and handles, and that's always been done through destructors. So C++ 2005 supports deterministic destruction and destructors for non-memory cleanup of managed objects. In C++, you supplement these things when you move on to the framework with the garbage collection and with finalizers, but you still retain your own idioms for destruction. C++ has had templates for many years now. The CLR supplements that with generics. The C++ programmer can choose how to mix and match templates and generics. In C++, we have native types. When we move on to the runtime, we add reference types, we add value types. These are types we can expose to other languages. These are types that serve all the same purposes that any object or class you would write in VB or C# can serve. But underneath the covers, if you want to use native types, if you want to use multiple inheritance, if you want to use the STL and the generic algorithms that are already written for you in the STL, they're there for you. One of the things I love about the .NET framework is the verifiability and the security. These things keep me safe, keep me from making silly errors of thought. And C++ supports these fully now, so I can write verifiable code, so I can write code that doesn't need to have full trust. That makes my C++ code first-class objects on the runtime. But I still have the things that make sense to me as a C++ programmer. So I can tell the difference between a pointer and what it's pointing at. I can write a copy constructor. I can write an operator, assignment operator, or a whole whack of operators, and write the way I'm used to writing. In the 2005 release of Visual C++, if you want to target the .NET framework, and I want to target the .NET framework, There's no reason why you have to leave C++ behind and move on to C#. You can do everything C# can, plus a whole lot more. That's why I still work in C++. Did I hit my time?
Well,